Okay, this is the video for 4.3a. Number 1 is asking for you to find the equation in standard form of the parabola passing through those 3 points. This is a long process, so I'm going to have to try to write small here, I think. So what we're going to do basically is we're going to be substituting these points individually into the standard form of a parabola. So y equals ax squared plus bx plus c. So I'm going to start with inputting the 1, 1 in here. When I do that, I'm going to substitute 1 in for y, 1 in for x, and when I do that, so 1 squared is 1, 1 times a is a, b times 1 is b, so I'm going to put b and then c. Next I'll do this one. So y, which is -3, equals ax squared. So we're squaring this and we're multiplying it by a. So -1 squared is 1. 1 times a is a. b times -1 would be -b, and then plus c. And then last, I'm going to substitute the third point. So y, 1, equals ax squared. So x squared is going to be 9, because -3 squared is 9. So 9a. b times x would be -3x, or sorry, -3b, and then plus c. So that's the first step for these problems, is you get an individual equation for each individual point. Once you do that, you're going to have to take a combination, 2 combinations of those 3. So what I'm going to do is I'm going to rewrite the first one and the second one right underneath it. And I'm going to take another combination. I'll do this second one and third one. I'll write those on top of one another. Now what we want to do is we want to eliminate the same variable here that we eliminate here. So what usually for these problems, eliminating c is always the easiest because c never has a coefficient. So I'm just going to multiply this one by that one by a negative. So I'm going to multiply the bottom by a negative. What I'm going to get is, actually, sorry, let's not do that. Let's multiply the top by a negative. Only because I can write it down here and it'll be lined up. So a negative times all of these is going to be -1 equals -a minus b minus c. When I add down, I'm going to get -4 equals -2b. What happened was these cancel and these cancel, which is nice, because when you divide now by -2 on both sides, you're going to get b equals 2. So that's going to be part of our answer that we're going to incorporate. So what we can do is we can substitute 2 here and here if we want, and then eliminate either a or c. So let's go right ahead and do that. Or we can just multiply the top by a negative up here to get rid of c, and then we'll be able to solve for a afterwards. So if I multiply the top by a negative, I'll have 3 equals -a plus b minus c. So this is my new, this was my new before. These cancel, so I'm going to have 4 equals 8a minus 2b. But I know what b is. b is 2, so I can go in and substitute 2 for b and then solve for a. If I add 4 over, I'm going to have 8 equals 8a, so a equals 1. That's going to be part of my answer. Finally, what I have to do is plug in 1 for a, 2 for b, and see what c is. So 1 equals a plus b plus c. So 1 equals 3 plus c. Subtract 3 from both sides. You get negative 2 is c. So after all of that work, what we can do is we can write out our final function. So f of x equals a, which is 1. So 1 times x squared is just x squared. Plus bx, so 2x, plus c, so minus 2. This here is actually your answer, not the ones that are circled. The ones that are circled are the things, the values that you plug in afterwards. Number 2, we're going to be doing the exact same thing. Remember, we're plugging it in to this formula. We're going to get 3 separate equations. So y equals ax squared, that's going to be 4a because negative 2 squared is 4, minus 2b plus c. That's our first one. Second one, remember we're going to be plugging 5 in for y, negative 4 in for x. We would get 5 equals 16a minus 4b plus c. And the next one, 0 equals a plus b plus c. Now I'm doing this quick because all you're doing is you're plugging in the value x and y here and simplifying it. These are the 3 that you would have. Alright, so I'm going to lump these first 2 together and then the second 2 together. So I would have 9 equals 4a minus 2b plus c. And then we'll have 5 equals 16a minus 4b plus c. I usually put a space here so that when I multiply, say the top one by a negative, I'll have some room down here to write it so that we'll have them right on top of one another. Plus 2b minus c. So this is my new for that one. So let's write these 2 on top of one another. So we'll have 5 equals 16a minus 4b plus c. And then the bottom one will be 0 equals a plus b plus c. I'm going to multiply the top by a negative. I'll get negative 5 equals negative 16a plus 4b minus c. I should be using a skinnier marker, but I'll have to fix that later. So this is my new. So when we add down, the c's cancel on both of them. That's the whole reason why we're multiplying by a negative. So this one gives me negative 4 equals 12a minus 2b. This one would give me negative 5 equals negative 15a plus 5b. Now we have to put these on top of one another. So I'll put this one underneath this one. So negative 5 equals negative 15a plus 5b. I'll put a space. Now I want to eliminate either a or b. So what I'm going to do is I'm going to have to multiply. Let me just erase this line here, because I'm going to need more room. I'm going to multiply the top by 5 and the bottom by 2. That will give me negative 10b over 10b, and those will cancel. So my 2 new equations, when I do that, I'm going to have negative 20 equals 60a minus 10b. In the bottom, I'll have negative 10 equals negative 30a plus 10b. So the b's cancel. we'll have negative 30 equals 30a. When you divide by 30, a is going to be negative 1. So we're going to need to remember that. So now let's stick negative 1 in for either this or this. Doesn't really make a difference. We'll do it in this one since it's smaller. So negative 4 equals 12a, which is negative 1, minus 2b. So negative 4 equals negative 12 minus 2b. Add 12 over. 8 equals negative 2b. Divide by negative 2. b is negative 4. Lastly, we have to plug in a and b and find c. So let's do that up here. I'm kind of running out of room. So 0 equals a plus b, so minus 4, plus c. So 0 equals negative 5 plus c. Add 5 over. c is 5. So my final answer, when all is said and done, is f of x equals a x squared, so negative 1 x squared, plus bx, so minus 4x, plus c, which is plus 5. So this here is my final answer, that function. It's a whole lot of work. Number 3. I'm going to do the same thing again. This is getting old, isn't it? So y equals ax squared plus bx plus c. Soon we'll throw in the calculator and make it real easy for you. Alright, so my 3 equations, when I plug them in, and you can do the work, but this is what you should get. The first point should give you 6 equals a minus b plus c. The second point should give you 4 equals a plus b plus c. The third point should give you 9 equals 4a plus 2b plus c. Let's lump these two together. So 6 equals a minus b plus c. 4 equals a plus b plus c. And then we'll lump these two together. So let's write that here. 4 equals a plus b plus c. 9 equals 4a plus 2b plus c. Alright, let's multiply the top by a negative on both of these. So we'll have negative 6 equals negative a plus b minus c. That's my new set. Negative 4 equals negative a minus b minus c. That's my new set here. Add down, the c's cancel on both of them. I'm going to get negative 2 equals a cancels. We get 2b here. When I divide, I'm going to get b equals negative 1 right off the bat. Over here, when I add down, I'm going to get 5 equals 3a plus b. But we just found out that b is negative 1. So 5 equals 3a minus 1. Add the 1 to the 5. Divide by 3. A is 2. So what we can do is we can plug in a and b for any of these up here and solve for c. Let's do the middle one. We'll have 4 equals a plus b plus c. So 4 equals 1 plus c. C equals 3 when you subtract 1 on both sides. My final answer is f of x equals ax squared plus bx plus c. And that's your answer. Well, that first page was pretty brutal. Number 4. So now we're going to start using a calculator. Determine whether the quadratic model exists, and if it does, write the model. What we have to do is we got to figure out if these points lie on a straight line or not. And you can draw a little graph just to see what it looks like. So negative 2, comma 7, 5, 6, 7 looks right over here. 0, 1 is right over here. Let's do that in a different color. So there's 0, 1 here. There's the other one. And then 2, 0 is right over here. Now you can see that there's a quadratic tendency because this doesn't lie in a straight line. It looks like it would go down and start curving here. So it looks like, yes, there is a quadratic model. What is that model? Well, that's when we take out our trusty calculator, this huge thing. Let me see if I can make it a little bit smaller. Maybe not. Let me try to do it with a mouse. Nope. Okay, so how am I going to fix this? Let me try. That's not going to work. Sorry about this. Let me just drag it down so you can see at least the keystrokes and stuff. You can't see the entire thing here, but you can see enough. So let's turn on the emulator and follow the rules in the steps that I gave you on that handout. So what we're going to do is we're going to go to Stat, Edit, and you should see this. What we're going to do now is we're going to enter the x values. So negative 2, 0, and 2. Negative 2, 0, and 2. Now we're going to enter the y values. 7, 1, and 0. 7, 1, 0. Now that all of those are in, we can get out of that. Now we're going to make the calculator do all the work. So we go to Stat, go over to Calculate. We want a quadratic for this, so we click 5, and then you just scroll down to Calculate, hit Enter, and you've got your answers right over here. Remember, when you're writing this in, well, I guess this is fine. You don't have to convert these to fractions. That's not necessary. So what the final answer should be is f of x equals, we can use those values, 0.625 x squared minus 1.75 x plus 1. That would be the answer, because when you plug A, B, and C into the standard form, that's what you get out of it. So that's that one. Number 5, let's bring in our calculator again. Let's get out of that. They're saying that a parabola has these 3 points. So what we're going to do is we're going to find the function of the quadratic, and then we're going to find, it says name another point on the parabola. I'll show you using the calculator how to get an additional point from here. So let's go back to Stat, Edit. Let's clear out the x value, the old x and y values. So clear, Enter, highlight L2, clear, Enter. Now let's enter these x values. Negative 1, 0, and 1. So negative 1, 0, 1. Let's plug the y's. 8, 4, and 2. 8, 4, 2. Now let's calculate. So go to that. 5, which is quadratic reg. Go down to Calculate. So there's our function. Well, let me write that down. So it's going to be y equals, it was 1, right? Yes. Why am I asking you? Like you can even talk to me and tell me if I'm right. Y equals 1x squared minus 3x plus 4. So there's your quadratic right there. If you want another point on the problem, you can stick anything you want in for x and get out another point. For example, we don't have the point when x is 2, so let's stick 2 in. Find out what we get. So y equals 4 minus 6 plus 4. So 8 minus 6 is 2. So we have the point 2 comma 2. That's also on the parabola. You could stick any point that you want, and that would be sufficient for this problem, what they're asking for. Number 6. This is a great problem where you can use your calculator. We have the time and temperature. So we're going to enter those in and get a quadratic. So let's clear this stuff out and enter x and y values. Now this is my x value. These are my y values. Whoops, that's not the best writing there. X and y. One thing you got to remember when you're doing this, especially for time, is if you're going to enter 6 for time, for 6 a.m., the second that you get past noon, you don't write 3 here. This is 3 hours after 12, so it's going to be 15. This will be 18. This will be 21. So you have to remember that. It's almost like you got to go into military time. So 12, 3 more hours is 15, then 18, then 21. So let's put these in. 62, 75, 85, 88, 84, 74. Let's quit, stat, calc, 5. Go down to calculate, enter. This is your answer, your quadratic. So we can round to the nearest hundredth or the nearest tenth, whichever you want, and write out the function. So it's going to be f of x equals negative 0.34x squared plus 10.02x plus 13.5. That's the quadratic for the time and temperature. Alright, so now we're at some review problems. Alright, a line passes through the point. What's the equation of the line in point slope form? So let's find out the slope first. So y2 minus y1 over x2 minus x1. We're going to have 7 over negative 5. So that's your slope. So let's just use this point here. Y minus y1 equals the slope times x minus x1. You could have used this point too. It doesn't make a difference. But this is one of the two answers that you could have. Number 8, graph the parabola. What we're going to do here is we're going to find the vertex first. So the opposite of b over 2a is going to be negative 1/4. Whoops. Goes negative 1/4. So the vertex is negative 1/4 comma something. So let's plug in negative 1/4 for x and solve for the output. So y equals 2 parentheses negative 1/4 squared is 1/16. 2 times 1/16 is 1/8. Let's make this eighths. It's going to be 2/8. Let's make that eighths. It's going to be 16/8. I'm tired of saying eighths. Y equals 1 minus 2 minus 16 is negative 17. So negative 17/8, which is negative 2 and 1/8. So if I go negative 1/4, negative 2 and 1/8, it's going to be roughly there. That's the vertex. What I'm going to do now is I'm not going to bother with this because the negative 2 is so close to the vertex it's really not even going to help me. So I'm going to plug in 2 and find out my output. So if I plug in 2 up here, I'm going to have y equals 2 times 2x, 2 times 2 squared plus 2 minus 2. This is 8 plus 2 minus 2 is 8. So 2 comma 8 is a point on the graph. Now for symmetry, remember this is at negative 1/4. So this point is 2 1/4 to the right. So from 1/4 I have to go 2 1/4 to the left. So if I subtract 2 1/4 from negative 1/4, because that's where I'm at right now, I'm going to be at negative 2.5. So this point here should be negative 2.5 comma 8. And then when I connect the points, that's my graph. So again, this is at 2, 8, and this one's going to be negative 2.5 comma 8. Okay, number 9. They want you to find the function in vertex form. So the first thing you're going to want to do is find the vertex. So we know that the x-coordinate of the vertex is located at the opposite of b over 2a. That's our h value. And then we can use the fact that once we have the h value, we can plug it back into the formula, to the equation. So we're going to have f of the opposite of b over 2a. That's just fancy notation, meaning that we're going to plug whatever we got for x back in to find out what we get for y. So the opposite of b over 2a. The opposite of negative 5 is positive 5. 2 times 2/5 is 4/5. So 5 over 1 divided by a fraction. What we're going to do is we're going to change it to multiplication and flip this fraction. So we're going to have 25/4. That's our h value. So to find out our k value, we're going to have to plug in 25/4 in for x here and here. So we're going to have y equals 2/5 times 25/4 squared minus 5 times 25/4 plus 3. (25/4) squared. That's going to be 25 squared, which is 625. So we're going to have 2/5 times 625 over 4 squared, which is 16. We're going to have all of that minus 5 over 1 times 25 over 4. So 5 times 25 is 125 over 4 plus 3. So y equals, there's a couple things we can cancel here. 2 goes into 16 8 times. 5 goes into 625 125 times. So we're going to have 125 over 8. Let me just erase this here. It's going to be over 8 minus, we're going to change this into eighths. So we have to double the denominator to make it 8. If we do that, we have to double the numerators. We're going to have 250. Plus, let's make this eighths. So if I make the denominator 8, it was a 1, I have to multiply the top by 8, so we're going to have 24. So all of this is going to be over 8, so we're going to have 125 minus 250 is negative 125, plus 24 is negative 101. So this is our h and k values. And our a value is 2/5. So this is a pretty ugly problem. But the answer is going to be y equals a, which is 2/5, parentheses, x minus h, so that's going to be 25/4, squared, plus k, so plus a minus is a minus, so minus 101 over 8. And this here is the answer. Explain why the domains for different models are sometimes different. Okay, well, different models. A model, it's been a long day. When you're modeling something, you're modeling potentially something that is a real-world situation. So it depends on the situation that you're dealt with. Are you dealing with speed, time, the number of days, the grade level that you're in? It all depends. So let's take, for example, the x-axis of a function represents time, let's say. Okay? If I'm looking at this is a very ugly coordinate system. Let me just do that over. This is still ugly, but less ugly. If I'm looking at the domain for that model, when I know that the domain is a set of all times, the domain has to be x greater than or equal to 0, because time only deals with positive time, like 4 seconds, 8 hours, things like that. It doesn't make any sense to have -4 hours. So it has to be the set of all x's such that x is greater than or equal to 0. You could have 0 time and positive time, but not negative time. A different thing would be if that's not really sophisticated language, is it? A different example would be if the x-axis represented the grade level and, let's say, your height. What if the problem stated or asked, since 6th grade, your height data went like this? Well, that would mean that your domain starts at 6 and goes up from there. So 6th grade, 7th, 8th, 9th, 10th grade, so on and so forth. So for that specific situation, your domain would be x is greater than or equal to 6. Or, for that matter, you could have a situation where the x-axis would represent something that you could have negative of. For example, I don't know, this is not that great of an example, but what the heck. This is the last problem of the day, right? If you could have x be the amount of money that you have, and y be the amount of self-confidence that you have, it would probably look like this, maybe. Right? The more money you have, the higher the self-confidence you have, which I'm not advocating, by the way. You could have no money and have a lot of self-confidence, which you should. But if you have a lot of debt, meaning like you're down $1,000 in the bank, that means you might not have that much self-confidence, or you might not be feeling that great that day. But then let's say you won the lottery and you're at 1,000, positive 1,000, then it goes up. So that domain could be the set of all reals, because you could have negative and positive values. So depending on the model, you can have different domains, because there are different sets of inputs that you could have for different situations. And that's it. Sorry it took so long, but number 1, 2, and 3 are just brutal. We'll talk about whether maybe on B you can do 2 longhand, the first and second longhand, third one with a calculator, and then for C you can do number 1 longhand and then the rest with a calculator. So remind me if I don't bring that up during class.